with my understanding, if I remember things correctly, we have river, something like this, and the dock is on one side, and there's a dock directly on the other side. Let me make sure I did this right. The river was going this way at 3 meters per second. The boat can be paddled at 5 meters per second in still water, correct? So the boat starts from the dock and has a velocity, something like this. I did have somebody in a different class not figure out why you would have to point your boat into the current in order to go straight across. That's a hard question to try and answer without chuckling a little bit. So I don't want you to ask it if it's you, but do you understand that if you tried to just point the boat that way, that you would hit the bank over here? You see that, right? That you trying to go straight across would push you off course. Now, you might try and always aim for the dock, say, but wouldn't that mean that you'd travel like this with yourself constantly trying to repoint the boat that way until you made it there? That's possible. That seems like the wrong way to go too. If you want to travel directly across, you start by pointing your boat in such a way that it anticipates the current. Does that make sense? I hope so. Because otherwise, I'm not sure I have a good way to explain it. It felt a lot like, well, obviously you would point it that way, but it was not so obvious this morning. I'm going to do something purposeful here. This stuff that we've been doing is largely procedural knowledge, meaning there's a procedure. If you follow it, you should be able to get to an answer. We don't have much more of that left. So for those of you who like having it scripted, so you just follow a set of steps and you can get to an answer, understand that goes away after a certain amount of time, and you actually have to do all the thinking for yourself. So there's some thinking to be done for yourself here, but there is a bit of a script that you can go by. I gave you that script. And part of that script was start by drawing in a coordinate system. Been saying that a lot, but that seems to be a missing point when I looked at all those papers I just turned back. So I'm going to start by scripting in a coordinate system. This is my coordinate system. I'm going to call this the positive x direction and this the positive y direction. You have to have something in place in which to make your measurements based. I'm going to base my measurements on this coordinate system. Does that make sense to all of you? That tells me the river is currently traveling in the positive y direction. But the boat is going to have to aim in such a way relative to the x-axis as to ensure that it travels directly across the river. So I'm going to talk about what I did before. I'm going to say I'm going to have boat and river, and I'm going to set up x and y, and then I'll have my result. I'm setting up some place to organize myself. The river's easy. It has 0 component in the x direction and 3 meters per second in the positive y direction. That is the velocity of the boat. I have converted the boat into rectangular coordinates. It was largely converted for me. The river, on the other hand, the boat, on the other hand, the river was largely converted to rectangular for me. I got to deal with the boat now. I'm not about rehashing stuff we've already supposedly learned, so I'm going to cut some corners here. But I am going to draw in a triangle here for those of you who are still, learning this and still needing some crutches here. I've drawn in a triangle. Is that a reasonable triangle I could use to replicate the portions of the boat's rectangular coordinates? I think so. It's aligned with my coordinate system appropriately. This is the opposite side. This is the adjacent side. And my hypotenuse is 5. I'm very confident that I can kind of skip the writing out sine theta and cosine theta. You should be able to, at this point, realize this one's going to have to be 5 sine theta. And this one's going to have to be 5 cosine theta. It's the result of going through your little checklist of things that are supposed to be on your trig cheat sheet and getting an expression for the opposite and adjacent side. Do I need to do this? I will, but this would be the last time. All right, I gave that 7 seconds of wait time. I feel that that's probably enough. So I've done it. I've taken my boat and I've converted it into rectangular coordinates. I don't have a numerical answer, but I don't need a numerical answer. That's not what this problem requires. 5 cosine theta and 5 sine theta. Based on the directions I've given, this would be positive and this would be negative. Now, here's where you have to be thoughtful. My result has to be a velocity that has no component in the y direction. If I want to go directly across the river, I need to have a velocity that has no component in the y direction, only components in the x direction. Well, that seems to give me what I'll have to do to figure out the angle. If I want to figure out the angle, -5 sine theta plus 3 has to equal 0. That's it. So sine theta is 3/5. That tells me it's a 3, 4, 5 triangle. So I'm assuming you guys know about 3, 4, 5 triangles. If not, check it out. 3 squared plus 4 squared equals 25 squared. So 3, 4, 5 triangle. But the angle, I think, is it 37 or 38 degrees? I can't remember. You gonna make me do it? You guys didn't do this? Thank you. But that also means that if I want to figure out the resulting velocity of the boat, that's got to be 5 cosine 37. Or in this case, 4 meters per second. Any question where I got that? We sure? Good. That's not the question, though. The question was, how long would it take for you to cross a 50-meter wide river? Well, I have to travel 50 meters. I'm traveling at 4 meters per second times t. How long is it going to take me to travel across the river? Looks like t is going to be 12.5 seconds. Little motion equation at the end. Not the level I want you to be working at, but getting closer. So I want to move on to something a little more difficult. Is that okay with you guys? Let's just increase the level of difficulty a small amount. All right. Track of. So let's say that we have a plane that's going to be landing and it has to be facing east to land on this runway. But let's say that there's a wind blowing at 30 meters per second, 60 degrees west of south. Now, for this one, we'll go with same level of difficulty. The plane has to have an airspeed of 120 meters per second to fall out of the sky. Any faster than that, it doesn't fall out of the sky. Any slower than that, it falls out too fast and hurts itself. We don't like that either. So the plane has to be traveling at 120 meters per second. That's its airspeed. What direction does the plane have to face in order for it to land on this runway? Again, the plane wants to be traveling due east. It has an airspeed of 120 meters per second. So the plane, 120 meters per second, but it needs to land going due east. I did not say the plane is traveling at 120 meters per second due east. I did not say that. I said the plane's airspeed is 120 meters per second, but the plane needs to be traveling due east or it runs off the runway. What direction does the plane have to face to make this landing? This is the same problem you just did. Set it up, please. You should be able to do this with the knowledge that you have now from the last problem. It is identical to the last problem. For all of you guys who don't know where to start, did you decide on a coordinate system? It doesn't have to be north, south, east, west. You go X, Y, Z, X, Y, and Z and all that. It's just as fine. You need to decide with your system what's positive and what's negative. Did you pick one of the vectors and start breaking it up into components? Drawing in the wind. Is this what you guys are doing? You guys are having trouble. I walked around and saw people just like staring at their paper, not looking up because they didn't want me to know that they couldn't do any of this. Look, you either prove you can't do it when you're practicing and it doesn't cost you anything, or you prove you can't do it tomorrow when I test you on it. Take your pick. But I'm going to have to know. So it's better to be asking questions now. How are we doing? The answer is 7 degrees north of east. Now, there's two possible angles, of course. You could have 83 degrees east of north. I'm indifferent to which angle you choose, but that would have to be the direction the plane points in order to land going down the runway. If you don't understand where I got that, well, the first thing I would want to do is break up the wind into its two components. Did you do that successfully? Let's see, because if that didn't happen successfully, whatever happens to the plane is going to be incorrect. I drew mine like this. Is that okay with all of you? So I'll start by there's my my components. I lined them up with the X and Y direction. I'm kind of noticing it's a 60-degree angle, so I'm pretty sure, without doing a whole bunch of math, this has got to be 15 and this has got to be 26. Okay. Because the cosine of 60 is half, and the sine of 60 is 0.866. So half of 30 is 15, and 0.866 times 30 is 25.99 or 26. Are we good? Do I need to do more work than this to show you those two values? Look, folks, I will do this, though, because I do need to be a reasonable teacher. This is A, this is O, this is H. Okay? So this has to be 30 cos 60, and this has to be 30 sine 60. All right. Either way, off to the side here, I'm going to put wind, X and Y, and plane, and result. The wind is negative 26 meters per second in the X direction and negative 15 meters per second in the Y direction. Now, you have two choices for the plane. And I say two because there are those among you who think a possible choice for the plane is to fly this way. But I don't want to land going that way. I want to land going towards the east on the runway. So I'm going to go this way on the runway. Does that make sense? I need to counter the wind, sure. But I just need to be going fast enough where I make progress in the east. And that would be a problem for me if the wind was so powerful that the plane couldn't fly faster than the wind. That would be a problem. And that is a problem. That's why they change the direction the planes land if the winds are too strong here. Or they reroute them entirely if the winds are too strong here. But now, the plane. I'm going to deal with, I think, two components. I'm going to have a component in this direction and a component in that direction. All I know is the hypotenuse, 120. I don't know the angle. It's fine. Opposite side is going to be 120 sine theta. The adjacent side is going to be 120 cosine theta. Yes, I want you to make it so that it's that effortless. You need to get there. Right? You need to get there. Both of those are in the positive direction. So I see 120 cosine theta in the x direction and 120 sine theta in the y direction. Well, I know the result has to have no velocity in the y direction. There you go. Again, the same kind of problem as before. There's more than that, though. If I actually want the speed of the plane down the runway, I do need to resolve this vector, which means to do 120 cosine 7 degrees minus 26. This is the actual speed of the plane down the runway, which is reduced due to the wind. There's tons of variations on this, but once you've done this a couple times, there's really not a lot to do here. All right, practice probably. Most runways aren't north-south or east-west. Most runways are given at an angle. But the winds are all given north, south, east, and west. What if you wanted to land your plane at a specific angle relative to the wind? For example, what if, and by what if I say this is like the next level of this problem, just so we all have an idea. What if I have a runway that's angled 20 degrees off of the east? What's funny is, anybody know anything about planes and stuff like that? They number runways based on the direction that they face. So this one, which is a runway that faces what direction? The runway doesn't face east. It faces at a direction relative to east, right? Faces towards the north a little bit too, doesn't it? And north is 0 degrees, east is 90 degrees. What direction is this runway? 70 degrees. This would be runway 7. The numbers on the runways basically are the direction of the runway. So there's a different number on this side. What do you think that side's number is? If I add 180 to 70, what do you get? So it would be runway 25. The Earth's magnetic field is changing enough where they're having to repaint runways. Now, if you did the math with us here, you understand that repainting a runway means it's changed enough where the 10th digit of its direction has changed. So the changing of the magnetic field is affecting the way we number these runways. They're not numbered based on actual north. They're numbered based on magnetic north because planes have magnetic compasses in them. And if everything else fails, the magnetic compass will still work. They can still find and navigate the runways. All right, so let's go with the same wind, just to make it easy-ish. The wind was 60 degrees. Uh, 60 degrees west of south. Same plane, 120 meter per second plane. And I want to land on this runway. This is as hard as the problems come. They won't be more difficult than this. And this is me just trying to exaggerate the level of difficulty of problems like this. So I want to be clear, this would not be a test question, but it's not because it's so terribly difficult. It won't be a test question because it just takes too long for you to perform it in a reasonable amount of time in class. You should be capable of doing this problem. Yeah. There's not a lot to do here. In fact, nothing changes from what we did a moment ago. But there is some geometry involved. So let me start by saying this problem is done by choosing an easier axis to work on. Remember, you choose the coordinate system. So right now, I'd say using the north, south, east, west coordinate system is not ideal. I would choose a different coordinate system. And if you don't know what coordinate system to use, how about one lined up with the answer? That would be the best. And we're going to do this a lot with forces. So remember, coordinate systems are arbitrary. You choose them. So I'm going to choose a coordinate system lined up with my answer. I want the plane to land on the runway. Now, whether that's this way on the runway or this way on the runway, that's going to be the coordinate system I'm going to use. One lined up with the runway. And just because I have to make a choice, let's say I want the plane to land this way. Okay? The problem is the same level of difficulty whether it lands the other way or this way. I'm going to make that the positive x direction, which means that there is a y direction as well. And I'll make this the positive y direction. What you need to do is, using the information given, figure out the angle of the wind relative to your new coordinate system. You need this angle. You have this angle. Or, well, you do have that angle. Right? It's 30 degrees because of the 60. So, let me remind you of north and south. The green coordinates were the ones given in the problem. You were told that this angle was 60 degrees and 30 meters per second. You need to figure out this angle. Now, there's a number of ways you could go about doing this. I don't think it's particularly a lot, but let's see if you can figure out that angle from what's written down here. I hope that you can. I'll give you a few minutes. If you think you have it, just raise your hand, and I'll come take a look at your hand. Look at what that angle is. All right. All right.
Oh wait, oh.
All right, there's a couple ways you could do it. Probably the easiest one that's laid out here is between this and this has to be 90 degrees. right? By definition, this has to be 20. We rotated to match the runway, and we rotated it 20 degrees. Well, that leaves 10 degrees for here. There's a couple other ways you could have done it. There are some vertical angles in here you could have used too. But once you know that, you don't need any of the other angles. You just use the coordinate system aligned with X and Y. But at the end, you do have to give all of your reference back to the original, which is north, south, east, and west. Try it out tonight.